And we're going to move on with Jasmine Collins' presentation. You already had a chance to check her tech setup before, so it should be a
Yeah.
smooth transition.
Hopefully, we'll see. All right. I had been told that there was still some like floating windows possibly earlier, so hopefully no
There
floating
possibly
windows
is one.
Yeah,
There is a
there is
small
one.
one.
now. Oh,
Jasmine,
So
do
I,
you,
it's
do you
here.
see any of the zoom elements on your screen?
I see it on my second screen, so I'm hiding those now. Did that do it?
no, someone says maybe because we are co-host and somehow that messes up the visual stuff going on. So maybe if you uh sign off as co-host and sign back in.
But I think Jasmine is a regular guest right now. I can try making
Hmm.
Oh,
a
okay.
co-host. I don't know if that makes a difference.
Oh, so
No.
Be surprised.
I hid my floating meeting controls here.
Try advancing your slide back and forth.
Okay.
No, okay. Still just the one in the bottom right, which you say
Bottom
there's
right.
nothing on your screen that shows up there, right?
No, I don't see anything. Is it like this spot?
Yeah.
Yeah, exactly that spot.
No, I just see the corner of my slide there. I wonder if I look at Zoom, is there?
Still.
Yeah, I don't even have the
Uh,
the
so you're
meeting.
saying on macOS you can use Control Option Command H to hide
Ah,
floating meeting controls, but
I am on Windows.
uh,
So then Lauren said it's like Control Alt Shift.
Control Alt Shift.
See what happens? No.
Anything?
No.
No, I'm not actually sure what that would be either because I don't have the
Is it on
video.
your other screen? Do you have like the other screen in that location something?
No, my other screen is like a separate one entirely.
Hmm.
Huh.
Well, then maybe we just kind of move on. Like, so there is
yeah.
that square that you noticed is indeed the part missing. So if you know there is something in that area, maybe you need to explain to the audience what is going on there.
Yeah, I
It's
can
not
do
it's
that.
not really bad. It's like it's a small corner of the screen that is missing.
Interesting. Okay, yeah, I have no idea what that is, but yeah, in the interest of time, I guess we can get started, and I'll just be sure to
Thank you.
describe anything you might be missing from over there. Okay, so well, hello everyone. I'm Jazmin Collins. I'm a PhD student at Cornell Tech working under Shiri Azenkot. So since we've been sitting on this title slide for a while, I'm sure at this point some of you might know what I'm talking about. I'm going to be talking about some of our work where we designed an AI guide that's meant to help enhance social VR accessibility for blind people. So, just diving right into that, I want to start by saying that virtual reality is visually complicated. And it gets even more complicated when you're dealing with VR spaces that are designed for multiple users, known as social VR applications, which can bring in dozens or sometimes even hundreds of other people into the same space. Now, on the screen right now, I have a picture that I like to show to sort of demonstrate what I mean about like visually complicated. In this image right now, there are two avatars, one with a cheeseburger for a head, another one with a toaster for a head and some bunny ears on top, and they're both making expressions and waving. There's some dynamic lighting in the background that's kind of forming this nightclub-like scene. There's important text on the walls, such as the name of the venue, Cobalt, in the background, and there are even interactable objects like a DJ booth with a DJ standing in front of it. There is a ton going on just in this one shot. And if a blind or low vision person who couldn't easily make out all of these visuals was trying to engage in this virtual reality space, they'd have a very hard time. In order for a blind or low vision person to even fully understand what this space is, all of this visual information needs to be made accessible. Now, in the past, some prior research approaches to improve this kind of VR accessibility issue have often used things like audio or VR haptic cues. For example, Zhao et al. Made tools that read out audio labels of important objects, like saying a pillow on a desk. And Collins and Jung et al. Designed a system of audio and haptic cues that could identify certain gestures made in virtual reality. However, while these kinds of approaches can work in more simplified VR environments, using those cues on everything that's inside of social VR would be overwhelming. So how do we make these really visually complex spaces accessible? Well, yesterday's keynote, if you saw it, introduced one approach that our lab has been exploring to this issue, which is bringing sighted guides into virtual reality. Now, as Shiri described yesterday in the keynote, these guides are inspired by the technique of sighted guide in the physical world. A blind or low vision person who's controlling an avatar in VR can use their controller to grab on to a sighted companion that's with them. And from that point on, until the blind person lets go, the two avatars form a unit, moving and teleporting together around the scene. Now, we developed this technique and tested it with 16 blind and low vision people in a previous study of ours, and found that it was a well-liked and versatile technique for exploring large virtual environments. However, the human guide also came with certain issues. Namely, it caused a lot of feelings of dependence on the human guide. And one of our participants explained these feelings pretty well by saying, I don't think there's anything that the guide could do to make the experience feel more independent, other than if we were to replace the human guide with an AI guide. I'm not relying on a person, I'm relying on software that I'm telling what to do. That's the difference between asking you to read the computer screen and me using the screen reader to read the computer screen. Now, based on feedback like this from Noah and several other participants who asked for AI guides for similar reasons, the next step that we had was to try making an AI version of our guide to support blind users in virtual reality. And for this talk, I'm going to dive really deep into the design process behind how we made this guide. And first, we are going to start off by talking about how we translated the human guide's features over into AI. Now, the human guide has two main abilities, navigation and visual interpretation, both of which require a user to be able to speak verbally to their guide, hear the guide's responses in return, and have the guide interpret the requests and respond accordingly, whether that's by taking them somewhere within the scene or describing a feature of it. To implement these core functions, we created a workflow for our AI guide that just starts in a VR scene that we built in Unity. A blind or low vision person might be in some sort of park scene, for example, near a river, and they might have questions about that, like what's the source of the water that they're hearing. They could want to tell the guide to take them to that source or just ask it to describe what's causing the sound of the water. But either way, once they have a query, they are going to start holding down a button to record the audio of that query in Unity. Now, at the same time, the system caches two images. One which is a screenshot of the user's viewpoint, and another which is a bird's eye view of the entire virtual reality scene, just to provide some additional context to the query. Then the user's query is sent to a speech-to-text API, saving it as text, and the images are temporarily stored online so that we have a public link that we can pass these images around in. Once we have those two pieces of information, the links and the text, we combine those together inside of a prompt that we've structured, which has specific instructions for how the AI should respond to different types of queries. So for example, it needs to provide the name of an object as well as a keyword like navigation if it decides the user wants to go somewhere. Then that whole prompt is sent to GPT-4, which answers it accordingly and provides a textual reply. We're not quite done there yet, because then we need to translate that textual reply with a text-to-speech API, turning it back into audio and streaming that audio in chunks as it's generated back to a user in virtual reality. Now, this reaches the user along with any other additional actions that we've coded into Unity, like triggering pathfinding algorithms for navigation. Okay. Now, with those basic features down, the next step that we have is figuring out what new features we want to implement into the AI guide. And to do this, we gathered feedback from our past participants with the human guide on what they thought were weaknesses of the guide or ways to improve it. Now, aside from the big challenge of independence that we mentioned earlier, we noted two key areas for improving the guide experience. First, people wish that the guide had more direct control over the virtual environment, instead of just walking them through it. And they thought that this could be way more powerful if the guide could actually make things more accessible for them, since they're in a digital world that the guide could easily manipulate. And And secondly, people also struggled with incompatible guiding styles with the human guide. And what that sort of means is that they didn't really mesh with the way the guide spoke, or perhaps they were uncomfortable with the guide's gender or appearance in virtual reality. Just in general, they wanted more options for different guides that they could feel comfortable with. Now, to address the issue with direct control, we implemented a new accessibility feature that we called audio beacons. So these are special sound effects that the guide can add to any object within the scene upon request from the user. So it provides a spatialized pinging sound effect that plays for around 10 seconds, and it allows the user to hear where certain objects are in relation to them. So now I will play a short clip here to give you an idea of what that audio beacon sounds like.
I remember there was a red thing here. Can you add a sound beacon to it? All right, I will add an audio beacon to red car.
Okay. Now, were you guys able to hear the audio inside of that?
Yes.
Okay, perfect. Just making sure. Great. And to address the big issue of guide incompatibility and guidance style incompatibility, we created a large feature that we called personas. So these are different combinations of avatar voices, appearances, and personalities that provide different guiding experiences. By instructing the AI with different roles or descriptors when we prompt it, we're able to change the way that it speaks, and we use that to kind of create the core of these varied experiences. Now, we designed 6 personas in total, an androgynous appearing human guide with black hair who spoke more like a tour guide, a silver humanoid robot with a militaristic formal way of speaking, a classic red and white striped white cane that only spoke in extremely short, blunt phrases, a guide dog, which was a German Shepherd breed dog wearing a red harness that was extremely friendly, enthusiastic, and chatty, and finally, a bright red bird that flapped over a user's shoulder and spoke in very dramatic Shakespearean sonnets. All of these vastly different guide personas were created in the hopes of providing varied guidance experiences. Okay, now finally, with all of our guide features complete, we took our initial designs and refined them through co-design sessions with blind and low vision participants. We conducted 1-hour-long sessions on Zoom with 6 blind and low vision co-designers. We held our sessions in such a way that we introduced the concept of the AI guide first, then performed a small demo of the guide in a Unity scene that it was built in, and discussed and implemented any alterations the co-designers wanted to the guide on the fly in that session so that we could get immediate feedback on them. The sessions focused on 4 aspects of the guide, which were personalities, voices, appearances, and abilities. Now, for some of the tools that we used things like OpenAI's text-to-speech playground to play around with various different voices and give people different samples of audio. And we used a Google Collaboratory notebook to make really fast calls to GPT-4 with different guidance prompts, as well as some preset images of certain VR scenes, so that users could play around with different sample questions, see how the guide responded, and also easily ask us to change the code inside the guide's prompt to switch up its response and see what worked better. Finally, we also had a test scene built in the Unity editor, and we allowed participants to suggest changes to the guide's avatars or changes to the code behind its abilities here in the Unity scene. Now, with all of these tools together, some of the suggestions that we ended up implementing based on these co-design sessions included things like giving a guide dog harness to our guide dog, so it really looked and represented a guide dog, or making the robot very shiny so that it was easy to follow around a scene. We also, through these co-design sessions, added a memo section to our GPT prompt with specific suggestions on how to improve responses for a blind or a low vision person, like using cardinal directions to describe where things are, instead of just vague references to that thing in front of you or that thing over there. All right, and so now originally what I wanted to have here were some demos of the different AI guide personas as they are now. But I actually recently discovered that the audio API, which we use for the guide, is no longer in service, as happens with technology. So currently the guide itself is out of action. So instead of showing current demos, I have an early demo of the human persona that I'm going to play instead. And then I'm going to read aloud a transcript from a different guide persona so you can hear the difference. So let's start with this demo of the human guide.
does the scene around me look like?
As the guide speaks, we look slowly around the environment, letting the guide tell us about it.
Welcome to this virtual world. Let me describe the scene around here for you. We're standing in a bright, open space with a clear blue sky above us.
Besides giving general descriptions, the guide can also answer visual questions. Now we look at the object in front of us, a tall yellow building.
What's the yellow stuff in front of me?
Ah, what you're looking at is the tall building. This impressive structure towers over the landscape, offering a unique perspective.
Now we're looking around the scene, and our gaze settles on the green shapes in the distance.
Can you take me to that green round thing?
We see the guide wait in place until our hand reaches out to grab it, and off we go.
All right, grab onto me and I will take you to landmark.
We glide together across the small test room and stop at the green object, with our arrival marked by a sound effect.
Okay, so that was a little mishmash video showing you all of the guide's abilities and capabilities in one. And now we're going to hear from a very different persona, which is the bird guide here. So to make this work, I want you guys to imagine that you're looking at the previous simple scene from just now, so the same basic colorful shapes that the guide described or that you saw in the video. You have this bright red bird who's flapping on your shoulder, and you just asked it where you are, what this place looks like. The bird responds, and I pulled up an example transcript from our testing of what kind of responses it gives. And I do recall that the bird's voice had a British accent, so I will do my best to replicate that for you all. But this is the bird's response. Thee find thyself amidst a land of simple geometry. Directly to thy front rests the sideways building, a recumbent yellow edifice that lies as though weary. To its right thou mayst observe the red car, its cylindrical form at pause. Behold to thy left the tall building soars, a beacon of golden hue. Further left, beyond the sideways building, be the landmark, an oval greenery, symbol of tranquility within this realm. And near to it, closer to thee, but still on thy left, stands the modest short building. This microcosm round thee is confined by ashen grounds and the grid that parts the earth beneath. What say you, traveller? Shall this observation suffice, or is there more to thine inquiry? So, I want you to know that I did not generate or write a single word of that. That is fully what the bird guide sounds like and fully the kinds of descriptions that it gives. I hope you enjoyed its little Shakespearean sonnet there. And more importantly, hopefully, you can see even from just that snippet how different the guidance experiences with these different personas can be. Now, just so that we don't go too crazy or over time, I'm going to end this talk by briefly talking about some future work we want to do with this guide tool. Obviously, our next step is that we want to actually evaluate it in studies. So we're planning on bringing in blind and low vision participants into our lab to actually try out this guide in various settings, possibly some settings like the parks that we tested the human guide in. However, that's not our only option for working with the AI guide here. After all, virtual reality scenes aren't always just based on parks or realistic environments taken from the physical world. A user could also be exploring an alien wasteland inside of VR. So we could try out some more complex or fantastical environments. And we could also give the AI guide more complex scenarios to try and help people in, like social scenarios where other people are accompanying the guidee inside of virtual reality. Now, in summary, we developed an AI-powered guide that was meant to enhance the accessibility of social virtual reality. We did that by transferring an existing guidance framework that we had of a human guide into AI, then implemented and refined the AI guide's features with blind and low vision co-designers. And finally, here at the very end, we identified some opportunities that our lab has for future work to evaluate these AI guides with blind and low vision users across various scenarios. So feel free to contact me if you have any questions. My email is jc2884@cornell.edu. And yeah, I don't know if we have time for questions since I know we're running over, but I'm happy to take any right now.
Maybe for one very quick question. So let me see the chat. Are there questions in the chat?
Yes. Yes, please start using recumbent yellow edifice to describe large yellow objects, everyone.
Okay, so outside of compliments about your voice acting,
Thank you.
professional career and possibilities, I don't see any questions in the chat, and I don't see anyone with any
Uh,
hands raised. So we'll move.
uh,
I'm sorry.
I did
Yes.
have one, because I've been wondering. Joe, I've seen this work a number of times, but I've always wanted to ask, when it comes to the different models that you used for the guides, how much do you feel like the shape versus the voice made a difference?
That is a really good question, and I think it depended on the participant who was using the guide. So, for
Mm.
example, with our blind participants, you might suspect the voice was obviously much more important than an appearance or the shape of the model. Especially in our co-design sessions, those participants, we had three blind, three low vision. The blind participants really put a lot more focus on playing around with the voices, picking a voice that they liked, or picking a voice that they at least thought was interesting and distinct from the other guide voices so that they could hear it really well. And interestingly, they also were a lot bigger into audio sounds that accompanied the models. So, for example, they wanted to pick sound clips of a dog walking across the floor to play as the dog guide was there, or the sound of a white cane tapping when it became a white cane so that they could hear those audio cues as well. Our low vision participants were way more, they found that altering the shapes and appearances of the guides was far more important for them. So, like with the robot guide I mentioned, one participant really wanted it to be very, very shiny because they said it would be good, make it easy to follow it around, make it easy to see. And they also really wanted it to be sort of large and taking up visual space so that they could always locate it very easily with their residual vision. So it kind of very much differed from person to person, but there was a bit of a trend for blind participants and users, those audio sound effects and pieces we put together were far more important for distinguishing personas and building an idea of them. And for low vision participants, that appearance was what they really honed in on and really liked.
Gotcha. Thank you.